And we're live. Okay. Let me see. Yes, it is called Slater.com. Here, let me pull this up for you and I'll show you what it looks like because it's super awesome. I have actually contributed some solutions because I went in and I just didn't like for example, there was one problem I was looking at and they had showed how to solve the problem using a strategy that you didn't learn until the next chapter. Well, that's stupid. Why would you even do that? Clearly, they were just sort of browsing around and were like, oh, I know how to do that problem. But they didn't actually know what you were doing in that class. So if you go to Slater, then you can find the exact book. You sort of have to find you got to watch out because there's different editions. You're looking for the one with the same cover. And then when you go to, wait, how did I end up on Quizlet?
I did too.
Yeah, it's moved is what it looks like.
Oh, but if you just type Slater.
Remove the Quizlet. That would make sense.
Okay, then. Okay, well, this may be less useful then. I don't know, because I don't know, this is the first I'd heard of this.
It looks like you still search.
Yeah, so
Yeah, it looks like it's like so.
let me see if I can find homework help and answers, which is what I want. So we're in chapter 2. This is actually already less useful.
What edition is it?
5th. It's the only one with a yellow cover too.
I found it.
They changed. Okay, so I guess they got links. They just go straight to the links. But anyway, when you go do this, you go to page 65, which is where the exercises are. Or let's say you wanted to look at a quick review, and then you can click on it. And what you'll see, to evaluate f of 2, we substitute x equals 2 in the given function, and then they show you doing it, which is f of 2 equals sine of pi times 2 over 2. And I'm assuming if you're signed in, it shows you more. I don't know. Let's find out because I have a Quizlet account. And oh yeah, so that's sine of pi, and we know that sine of pi is equal to 0, and there are no more steps. And then sometimes you'll get more than one. See, this says 1 of 2 steps. Oh. Sometimes you'll get more than one explanation because, like, I've gone in and like that person who put in how to solve it using something that we didn't even cover until like a whole chapter later. So I commented on that, and then I put in my own solution saying this is a better strategy for where you are in the book. Yeah.
It says you only have like 2 free explanations, so you probably need like a premium account or something. It's like unlimited. Because you have 1 free explanation left. Oh.
Any questions about things not called Slater.com? Because apparently it just got crummy. And here's the thing, you know what? It cost them nothing except the cost of the servers. It was just this great website that you just find your book and then you type in the page number and it would pop up with a list of the questions on that page. All it cost them was servers. How much could servers possibly cost in 2021? Virtually nothing. And they've ruined it. Oh well.
Big Quizlet.
Yeah. Now I hate Quizlet. Now I'm going to boycott them. All right. Guys, any questions? Any math questions? Anything out of the book? I'm not going to talk to you about 2.2 today. I'm not here tomorrow. Is today Thursday?
Yeah.
I will answer your questions today. The 2.1 quiz will drop into formative when school ends. It'll be open until class starts on Monday. Please get it done. On Monday, I will give my 10-minute recap of 2.2. since I'm not here tomorrow. And then the 2.2 quiz will be at the end of next week, probably along with 2.3 quiz. Something like that. Yes.
Connor, Michael, Gary, Jenica, and I will all be gone tomorrow.
See, I won't care, okay?
Just so you know.
Because I'm not
Oh my
here.
God, it's really slow.
Did you all say it was gonna be gone?
Doesn't matter if it wasn't you,
Connor,
right?
Michael,
No, don't say it again. He doesn't need to know.
Well, I mean, just because it doesn't matter with me.
All right. Questions. What questions do you have on math problems? What would you like me to go over? What would you like me to talk about? Jenica.
Can we go over exercise 31?
Of course I can. Let me get my calculus book. Since I don't have them all memorized yet. That's my goal for this year. And Jenica, are we still in 2.1 or have we moved into 2.2?
2.2.
All right, thank you. 2.2, exercise 31. Find the vertical asymptotes. Describe the behavior on each side of the vertical asymptotes. F of x equals cotangent. Somebody tell me what cotangent is?
And there's gonna be which was on top and which was on bottom.
Also known as 1 over tangent. So we don't have to say big long explanation. Tangent is sine over cosine, agreed? And anytime you have 1 over a fraction, that's just the same as the reciprocal of the fraction. So cotangent is actually defined as cosine over sine. When do you have a vertical asymptote? Come on, this is algebra 2. Straight up basic algebra 2.
Vertical.
Vertical asymptote. What has to be true of your giant big polynomial fraction? To have a vertical asymptote, remember you had holes in asymptotes? Where did you find the asymptotes? Nothing? You get a vertical asymptote when something in the denominator equals 0. Remember, you get a hole in the graph when you have a 1 in your fraction. So if you've got the same thing top and bottom and they reduce, you get a hole in the graph. If you have something in the bottom that's equal to 0 and it doesn't reduce, you get an asymptote. Mr. Guyash likes to say it's really important that you know your asymptote from a hole in the graph. Think about it. Think about it. Okay, there we go. So we will have a vertical asymptote whenever sine of x is equal to 0. When does sine of x equal 0? Visualize. Where does sine start? Unit circle. Sine is defined as? Where's sine on this circle?
The length away from the y-axis.
Yeah. Remember that?
Or x-axis.
No, away from the y-axis. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's how we knew that that was sine. That's how we knew that that was cosine, because as soon as we made this 1, that length had to be sine of this angle. Yeah. Okay. So, and guys, this is something that you really should have down cold. You should know it. Go back and review it and memorize the unit circle. Because we know that sine is equal to 0 at an angle of 0. And we know that sine is equal to 0 every pi units thereafter. The way we normally say that is we'd say 2k plus 1 pi. Do we have to? No, we don't even have to. We can just say pi. Plus or minus k pi, where k is an integer or a whole number. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, sine will always be equal to 0. Every half a circle, sine is equal to 0. Going backwards, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, sine will be equal to 0. You get a vertical asymptote at every single one of those places. Now, the next question, and this is basic analysis. This is how you determine if something has vertical asymptotes. As soon as you see a fraction in a function, immediately you should be thinking to yourself, well, hey, is there anything on the bottom that could be equal to 0? Because if there is, I've probably got a vertical asymptote. That's a lot of what we were doing in Algebra 2 is getting comfortable with all those different functions so that we didn't have to spend time trying to figure these things out. And I know it's been 2 years of hell since you learned all that stuff. Makes it harder. But you know what? Everybody else is in the same boat, so don't worry about it. Now, what happens at those vertical asymptotes? So if I'm drawing a graph, I know that I'm going to have a vertical asymptote here at 0. I'm going to have one here at pi. I'm going to have one here at 2 pi. And then the question is, well, now what? What happens on either side of those vertical asymptotes? So what you have to do, what you want to do is think about the graph of sine and say, well, what is sine doing as I get closer and closer to pi? Well, do we agree that sine is becoming a smaller positive? Well, how about cosine? Cosine looks like that. So what's cosine doing as I approach pi?
Dropping.
Also known as becoming a larger negative, agreed? Well, what happens if I divide an increasingly large negative by an increasingly small positive? Large negative divided by small positive? My vertical asymptote is going downwards as I come from that side. Because my equation tells me to take some negative that's getting closer and closer and closer to 1 and divide it by some positive that's getting closer and closer and closer to 0. Well, the limit as I go -1 divided by 0, because I can't actually divide by 0, the limit as I look at -1 over 0 is going to be a very, very large negative number. That makes sense? And then I can do the same thing on the other side. So let's look at what's happening over here. What's happening here as I get closer and closer to pi? Small negative. And over here? Closer and closer to pi? Still large negative. And when I say large, I mean 1. But it is still, relative to 0, a large negative. So what does my asymptote do on this side of pi? Large negative divided by small negative. There's only two possibilities. Just take a wild guess. Positive. There we go. Negative over negative. Boom. So cotangent would appear to have a graph that looks something like that, where I've just got a whole bunch of these things. Apparently. But it makes sense unless I did something completely wrong. Does that help as far as how you analyze this kind of problem? And of course, the hint is they told you vertical asymptotes. So you know what you're looking for, as opposed to here's a function, investigate. At which point, one of the things you would say, because we all remember the list of 9 things that were involved in an investigation, one of them was asymptotes. More questions? Next problem. None? That's the only problem we have any questions about right now? Danica?
45.
45. 2.2 still?
Yep.
Good. Find, end behavior models. I love end behavior models. In fact, on Monday, I'm going to show you a cool video about end behaviors. I'm also going to talk more about end behavior models on Monday. But we will talk about this now. End behavior model says, I have a function and inside this box, it looks like something. I don't know what it looks like right now. Don't care what it looks like right now. The question on end behavior models what does it do out there? Y equals some quadratic function. Inside the blue box, it's got a U shape because it's quadratic, and it's got a vertex, and it's got some intercepts, and it's either flat or it's narrow or it's upside down. We know that. But the end behavior is a positive quadratic goes to infinity and beyond. That's the end behavior. What do quadratics do? They do that. That's how you can think about end behavior. Remember the hand graphs where everybody put your hand in a quadratic and you went like that? Well, that's end behavior. Here's all the junk in the middle, which is that blue box, and here's my end behavior. My hands are both sticking up like this. A negative quadratic, boom. I have to. I can't help it. I go like this, and then all of a sudden I have to go like that. It's weird. It's like this physical reflex that I cannot stop. So a negative quadratic will have this end behavior model. Now, that's really big. That's algebra 2. That's baby stuff. Advanced math, which is where we are, says, okay, can I model the end behavior with some function? So if I were to say to you, for example, here's my quadratic. Y equals 2x squared plus 3x plus 1. And I say, what's the end behavior? Does the 3x or the plus 1 tell you anything about the end behavior? No. The only thing you care about is that, oh, look, 2x squared. There's your end behavior. So my end behavior model, I'm going to change this to f of x, just because that's the notation we're using in the book. My end behavior model, EBM, is that thing right there. G of x equals 2x squared. Now, we all know, we all agree that that's an end behavior model because quadratics are so darn easy. Hey, look, 2x squared, boom. Goes up in both directions. End behavior model. Done. It's not always that easy, and here's the problem. That is not a mathematical argument. That is a duh, I took algebra 2 argument. But a mathematical argument says, well, how do I prove that's an end behavior model? Well, to prove that something's an end behavior model, I could say, well, when x is huge, f of x over g of x equals 1. For a huge x, 1 quadrillion. Well, 1 quadrillion squared is so big that it doesn't even have a name. But 1 quadrillion squared is 1, 2, 3, 4, 5, 6. There's hundreds, thousands, millions, trillions. There's 1 quadrillion.
You forgot billion.
Hundreds, thousands, millions, billions, quadrillions. 1 quadrillion squared, 1, 2, 3, 4, 5, has 3, 4, 5. There's 1 quadrillion squared. And I'm multiplying it by 2. What I am. That's significant. Hey, Willem, I've decided to leave you my fortune. It's 1 quadrillion. No, it's 2 quadrillion. And then I die. And the lawyer says, here's your check for 1 quadrillion. You're like, oh my God, you totally hosed me out of a whole quadrillion dollars. What a ripoff. Plus, plus 1.
Got one right there.
2, 1, 2, 3, 4, 5. Guys, do you see the point? This is negligible. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal points away from the leading number. It's negligible. And I'm only talking quadrillions here. Let's make it quintillion. Sextillion, septillion, octillion, nontillion, decatillion. Every time you do that, this number moves way over here, and that number moves a little bit over here. This becomes insignificant. As big a number as it might seem, it is insignificant compared to the big number. Somebody gives you $100,000, but actually they give you $99,999.99. Would you care really? because 1 penny less than 100 is insignificant, it doesn't matter. So when we are dealing with end behavior models, what we're talking about is what matters. And what matters is the big one. What we will refer to as the dominant function. The dominant function in this sum of 3 functions is the squared. As x goes to infinity, these things become less and less significant to the point where they're irrelevant. They don't tell you anything about what the function does. This function is going up and to the right. Even if this were a minus 3x, hey, guess what? This function's going up and to the right. Because subtracting this still isn't going to make that much of a difference. So here's what I'm looking for. Anytime I'm looking for an end behavior model, I look at the function, I say, what is the dominant function? I choose what I believe to be the dominant function. And then I say, okay, does this equal 1? If it does, then I chose the correct dominant function. If it doesn't, I chose the wrong dominant function. Let me give you a counter example of choosing the wrong dominant function. I am going to choose, I was reading an article about a guy who was talking about his math teacher was doing one of these things where he just like had to write all these zeros on the board, except his door was at the other side. And he was writing the zeros and he wrote and he wrote and he wrote and he walked out the door and he didn't come back. And so the whole class was sitting there waiting and waiting. And after a while, they're like, where'd the math teacher go? he went to the staff room and read a newspaper and had a cup of coffee. Let's choose g of x equals 3x. Let's assume that this is a more complicated problem and it's not completely obvious. So here's what I do is I say, okay, well, what's the limit as x goes to infinity of 2x squared plus 3x plus 1 over 3x? Let's see what that does. Is it equal to 1? Equals 1 question mark. Well, that's a fraction, agreed? So I could split this into 3 fractions, 2x squared over 3x plus 3x over 3x plus 1 over 3x. We all comfortable with that? Okay. And now one of the properties of the limit says I can take the limit of each of those things separately. So this will be the limit as x goes to infinity of, well, the first thing is actually 2/3 x. The second thing is 1, and the third thing is still 1 over 3x. Is that equal to 1? No. This is infinity, which means that 3x is not the end behavior model because it doesn't equal 1 when I figure it out. This is a guess and check process based on your knowledge of functions. Which is the dominant function? Test. Get it wrong? It won't be 1. Pick a different dominant function. Howdy! Things happen. Guys, are we okay with that? The concept of dominant functions is going to be a big deal. And really, it requires you to know what all those different functions are. Again, going back to the purpose of Algebra 2 was so that those 13 or 14 functions that you learned down cold, you knew everything about them, all those investigations that we did, payback. Everything you did in Algebra 2 now gets paid back because you could look at these and go, oh yeah, I know that this goes up faster than that. Because this is a quadratic, and quadratic go faster than linear, so 2x squared goes up faster than 3x, boom. You don't have to sit around for 20 minutes trying to figure out which one goes up faster. You can just say, hey, I know this one. There's that, and there's that. Got it. All right. Is that more than you wanted to know, Jenica, or is that good? Cool. Anything else? More questions you want to ask? Any other problems? Gary, you may wish to go back at some point and watch the video where I go through the explanations, because we did 2 problems. We did 31 and then this one, and the explanation was far more than what you see on the board. Yes, what's written on the board is the detritus of the explanation. And it doesn't make a ton of sense without me explaining each step. All right. If that's all you got, the rest of the time is yours. I know you probably know this because you're not stupid freshmen. I had a freshman in my calculus class once, and I forgot I had a freshman in my calculus class, and I made some comment about freshmen. What?
I'm the age of a freshman, technically.
Yeah, but you're not a freshman.
Yeah, sure.
Yeah, see, we don't care. But no, it was quite funny because I made some comment about how much we all hated freshmen. And all of a sudden I looked at him shrinking down in his chair and it's like, oh, I'm so sorry, I forgot. You don't count. You're in calculus. You don't qualify as a real freshman, so you're okay. Okay. Don't forget, lunch is based on 5th period today. So don't go rushing off to 4th. You don't have 4th. Don't go rushing off to lunch because your 4th period teacher has first lunch. You may not have first lunch, so. All right, cool. It's all you. Go.